Okay, so for the last problem of the day, we're doing problem number 9 on page 5 in your packet. This is a nice problem. It's similar to what you may see on a free response portion of the test. So they want us to find the coordinates of P in terms of T, given this information. So we have to notice that what we're given is dx dt and dy dt. So basically, this question sounds confusing, but actually what it's asking us to write is P of t as a vector. So they're asking us to write P of t as a vector. And so to do that, we need to find x and y. So like we did in the last video, x will equal to the integral of dx dt, which is x is equal to the integral of 1 over t plus 1. And we know that the integral of 1 over t plus 1 is equal to, so x is equal to the natural log of 1 over t plus 1 plus c. Now, we're given some initial conditions here. We know that when t is equal to 1, that x is equal to the natural log of 2. So we're going to do some replacement. And yes, I know I just wrote that wrong. Sorry. It's equal to t plus 1. I know that. Okay, sorry about that. All right. So we're going to do some replacement here. So when x is equal to the natural log of 2, t is equal to 1, which gives us the natural log of 2 plus c. So we see that c is equal to 0, so our x coordinate would be the natural log of t plus 1. Now we need to find y of t. So y of t is going to equal to the integral of 2t, which is our dy dt. So integrating that, we get y is equal to t squared plus c. The initial condition we're given is that when t is equal to 1, y is equal to 0. So we get c is equal to negative 1. So y is equal to t squared minus 1. So to write this in vector form for P, we will write the x-coordinate, which is the natural log of t plus 1, comma, our y component, which is y squared minus 1. And that answers A. For B, we're going to have to go back to what we just wrote. So we know that T, let's write it like this. We know that X is equal to the natural log of T plus 1, and we know that Y is equal to T squared minus 1. And they want us to write an expression for y in terms of x. So that is just eliminating the parameter is what they're asking us to do here. So I'm going to start by solving for t in this expression. So if I exponentiate both sides, I get e to the x is equal to t plus 1. So t is equal to e to the x minus 1. I take this t and I replace it for y, and I get y is equal to e to the x minus 1 squared minus 1. Now, for a free response question, you could leave it just like that, but I'm going to simplify it a little bit and multiply this out. I get x to the 2x minus 2e to the x plus 1, and then minus the 1 on the end. So y is equal to e to the 2x minus 2e to the x. And that is my answer for B. For the next question, it asks us to find the average rate of change. Well, we have to remember the average rate of change is f of B minus f of A over B minus A. And in the last problem, we found f of x is e to the 2x. So y is equal to e to the 2x minus 2e to the x. So we need to find f of b minus f of a over b minus a. However, we have a problem. This is given in terms of x, and this is given in terms of t. So I need to find out what x is and what y is when t is 0 and when t is 4. So I need to find x of 4 and I need to find x of 0. I need to find y of 4 and y of 0. So to find x of 4, I'm going to have to go back to our original equation, and we know that x is equal to, we said in part A, that x is equal to the natural log of, was it t plus 1? So x of 4 then is going to be the natural log of 5. X of 0 is going to be the natural log of 1, which is 0. Therefore, y of 4 is going to equal to, now I take this x that I have and I replace it for this x to find y. So then y of 4 is going to equal to, I don't have enough room there, so I write it here, e to the 2 natural log of 5 minus 2e to the natural log of 5, and which simplifies to natural log of 25, because this comes up and becomes the natural log of 5 squared, and e to the natural log of 5 squared is just 5 squared, so y of 4 becomes 25, and minus, sorry, still have to do this one, 2e to the natural log of 5 is just 5, so minus 10, so y of 4 is equal to 15. And then y of 0, when we replace x of 0 here, y of 0 then would be e to the 2 times 0, which is 0, minus 2e to the 0, and that's going to give me negative 2. I'm sorry, negative 1. Sorry, bad math, because this is 1 minus 2, so that gives me negative 1. So these are the values that I'm going to use in this expression. So f of, so it's f of 4, which in this case is 15, minus f of 0, which is negative 1, over 4 minus 0. So that is 16 over 4, which is 4. Actually, it's got to be x. These have to be x values, so we have to be very careful here because these are t values, but this has to be x values. So this would be the natural log of 5 minus the minus 0. So my answer is 16. I've made a mess here, sorry. Erase all of this. Can we go back? These are x values. So this is x of 0 minus x of 4 minus x of 0, which would be the natural log of 5 minus 0. So my answer is going to be 16 over the natural log of 5. Yes. Okay, so one of the things you have to remember with parametrics is you have to keep your x and your y terms straight, and I didn't do a very good job of that. One last thing, let's find the instantaneous rate of change. And the instantaneous rate of change is simply going to be the slope. So we have to find the slope of y with respect to x. So this is dy dx. And remember, dy dx is going to be dy dt divided by dx dt. So once again, we have to recall our values of x. X is equal to the natural log of t plus 1. No, we don't have to do that. We know dy dt and we know dx dt. We were given those. So dy dt is 2t, dx dt is 1 over t plus 1. And we are evaluating that at t equals 1. So when we evaluate dy dx at t equals 1, we get 2 over 1 plus 1, which is 2 over a half, which is 4. Okay? So that is that for that problem. Thank you for watching the videos, and I will see you tomorrow. We will practice more of this tomorrow.